Signals that wouldn't die, 1980s intercepts and ghost pings. From geometry to sound. While public attention stayed on rockets and flags, the listening posts took the night shift. In the early 1980s, a signals officer at a quiet Pacific site started logging a tone that didn't fit any catalog. Not a beacon, not a satellite signal, not radar spill. It was a metronome with manners, clean spacing, same rise, same fall, like it was built, not natural. He wrote, unknown cadence, non-terrestrial timing base, in the margin. His supervisor crossed out non, told him to file it under space weather. Here are the stakes. If a pattern repeats at moon distance, stays cleaner than most commercial systems, and shows up only when certain orbits go busy, you've got two choices. Either we built something we didn't admit, or someone else did, and put it where we pretend only gravity sits. The officer noticed one more thing. The pings clustered when Cislunar launch windows stacked, especially during long burns that crossed the Earth-Moon line. He didn't know the word Lagrange. He learned by listening. Other stations started hearing the same thing. Greenland, Guam, a desert array in Australia. Each site recorded short bursts, 3 pings, then silence, with very steady timing that shifted a little, like the source was moving around the moon. When the moon set, the pattern faded. When it rose, the pattern returned, but not at the same clock time. Operators compared notes over bad coffee and radios that weren't supposed to cross-link. They called them ghost pings because nothing plotted on a map. You couldn't triangulate from Earth. The angles were wrong. The distance felt trapped behind the far side. Action, then a human moment. Night watch, fluorescent hum. A printer fighting a stack of green bar paper. The system flags a sequence. 9 pings, same spacing, then a gap equal to 3 spacings, then 9 again. The officer prints it and walks it down a corridor. At a door marked with a numbering scheme only base supply could love, a civilian in a plain sweater takes the paper, thanks him, and says, "We'll reconcile the clock drift." It sounds helpful. Next morning, the officer checks the archive. The file is there, time-stamped, labeled, but the waveform is blank. A perfect rectangle of white where the signal used to be. People in other fields saw the same kind of structure. Radio astronomers scanning low bands for space, weather found repeating features where the sun shouldn't be. Microwave engineers testing antennas heard a faint comb on nights when the moon sat high. A naval site tracking deep space noted unexplained ranges in cislunar returns that went away when someone called it ionospheric. Meanwhile, the ghost pings kept their manners, clean, periodic, modest power. Like a lighthouse you only see if you know when to look. This was the moment everything changed, though nobody said it out loud. Engineers built filters to strip the pings out of routine data. Schedulers learned to avoid certain windows if they wanted clean baselines. The phenomenon became maintenance, not mystery. But the pattern didn't quit. When heavy traffic headed toward the Earth-Moon line, the pings got stronger, like a network upstream woke up to take attendance. When a bad debris scare hit high orbit, the pings changed tempo, then calmed. No official link. Just operators keeping private notebooks. Impact. A few analysts stacked the ping intervals against models of a node near L2 sweeping a beam, while timing passes across L4 and L5. The math lined up. Not classic radar. More like a handshake between clocks. Status checks inside a system, making sure its edges match. The ghost pings sounded less like messages to us, and more like the network talking to itself. Microstory. A junior tech at an inland site notices the printer jams whenever the pings hit. Not random. The data buffer overflows when the filter kicks in. She clears the queue and watches a single sheet slide out with half a waveform before the blanking routine erases the rest. She tucks it into a book and forgets it. Years later, moving day, the sheet falls out. The time code at the top matches a launch she watched on TV. The intervals align with a tranlunar injection burned to the minute. Meanwhile, official language hardened. Air Force reporting forms added boxes for orbital anomalies. A note reminded operators not to use the phrase non-human. The all-domain office later echoed that in public testimony, but behavior on the floor told the truth. Everyone planned around the pings. You don't plan around artifacts. You plan around actors. In the aftermath, the listening posts did what they do: listen. The ghost pings never declared intent. They never turned into speech. They just framed our busiest moments with a quiet metronome that matched cislunar geometry too neatly to ignore. And as the decade turned, the same signals officers wore patches that said Space Force. They weren't arguing if the pings were real. They were writing playbooks for when the pattern changed. Space Force changes the language. By the time the ghost pings became part of the night shift's weather, the uniforms changed, and so did the verbs. Track turned into characterize. Interference turned into anomaly. Inside briefings, the phrase unattributed behavior replaced every guess anyone wanted to say out loud. Then a document landed with the weight of bureaucracy. The Space Force's Data and Artificial Intelligence Strategic Action Plan for 2025. On the surface, it read like culture change, governance, literacy, partnerships. Between the lines, it sounded like survival in an environment that refused to be cataloged by legacy models. Stakes first. If the service in charge of Orbital Order starts teaching every Guardian to speak AI, it's not about buzzwords. It's because the sky is producing more signals than humans can parse, and some of those signals don't behave like debris, satellites, or meteorology. The plan mandated AI fluency, not optional training. Operators needed systems that could notice patterns across orbital layers in real time. Surface sensors, mid-atmosphere returns, orbital tracks, and cislunar transits. Then correlate them with the unknowns without jamming every feed with false positives. You don't restructure your force to chase noise. You adapt to an opponent you won't name. Action. March 2025, the plan goes live. For lines of effort, clean data, teach everyone field analytics fast, plug into industry and allies. The internal translation at unit level was simpler. Fuse every camera, radar, telescope, and commercial feed you can lease. Let the machines flag what your doctrine doesn't recognize, don't miss. Contracts rolled out to tie in commercial constellations, wide-field ground sensors, and private radar. A Guardian at a mountain site watched a new dashboard bloom with tiles, air, orbit, geosynchronous, cislunar, each colored by an anomaly score. The pings he'd been trained to ignore now had their own lane, scored, time-stamped, cross-checked with launch schedules he didn't have clearance to see. Microstory. Utah Valley, winter dust settling on pasture fences. Before dawn, unmarked vehicles slid in with masts that rose like bare trees, portable arrays, self-contained. Locals filmed from kitchen windows. The team put down cables, powered up, and the valley hummed with a tone no one could hear, but some people felt. Hours later, witnesses caught 3 luminous points holding a triangle low over the ridge, steady in a way wind can't explain, then fading. The next day the gear was gone, grass laid flat where it stood. Officially nothing happened. In the logs, that valley now had a tag and an anomaly trendline. Meanwhile, testimony stayed cautious. The All-Domain office repeated the familiar line: no verifiable evidence of extraterrestrial technology. The Space Force didn't contradict them. It didn't have to. Behavior tells the truth quicker than language. New playbooks circulated for orbital anomaly management, a phrase that puts a leash on panic. Procedures detailed how to maintain comms continuity during non-cooperative interference without attributing source. Another section described temporary no-fly slivers during spectral congestion events. In practice, it meant commanders had authority to clear lanes when the net tightened. Nobody used the word Sentinel. They didn't need to. What nobody outside the fence knew was how quickly the machine correlations changed day jobs. A Guardian in Colorado watched an AI layer stack ghost pings, L2 geometry, and civilian interference reports into a single timeline. The system would nudge an alert when launch traffic on one coast increased the anomaly score over the far hemisphere minutes later. It felt like seeing weather fronts where the map used to be a blank. He printed nothing. Paper had a way of getting lost. This was the moment everything changed, though it looked like normal staff work. The service published guidance on multi-layer anomaly adjudication, teaching crews to treat the unknown like a managed participant. Deconflict, buffer, resume. Commercial partners got letters about cooperative spectral stewardship and quiet upgrades to their telemetry pipelines. Universities found themselves invited to join experiments on non-kinetic resilience during busy windows, the kind of phrasing that soothes when what you're doing is bracing for a hand you can't see to press into the network. Impact. Language shifts became rules. Orbital anomalies is a phrase that admits persistence without conceding origin. AI literacy requirements turn intuition into workflow. Don't argue the ghost pings, measure what they do to your links. The partnerships bring civilian sky feeds into the same room as classified tracks, giving the machine the widest lens possible. And beneath the denials, deployment patterns draw a silhouette. Arrays in valleys before orbs appear. Temporary comm reroutes when L1 and L2 corridors go busy. Drills that rehearse keeping aircraft safe while overhead geometry holds steady and unreadable. Microstory. Night shift briefing at Vandenberg. A captain points to a strip of airspace and says, "Expect congestion not reflected on public schedules." The room stays quiet. Pilots adjust fuel plans. Controllers mark windows. Nobody says why. Hours later, 3 steady returns hang too still to be weather, too quiet to be traffic, and exactly where the machine said they'd be. Everyone goes home on time. Nothing to report. In the aftermath, the Force didn't claim a discovery. It normalized a posture. Train the people, wire the feeds, let the machine surface the patterns, write procedures around the behavior, and keep the nouns bland. By changing the language, they gave operators a way to act without a speech about what's up there. Which of course leads to the next reveal. When the moon becomes the quiet center of a loud sky, you start noticing when the corridors through L1 and L2 run hot. The 2026 wake-up, lunar corridors go hot. It started as nuisance reports from companies that never admit nuisance. Telemetry hiccups on translunar trajectories. Star trackers drifting off solutions for seconds at a time. Narrowband comm links losing lock exactly as vehicles cross the invisible line between Earth and the Moon. Internally, project managers wrote, "transient interference." Externally, press releases said nothing. But by late winter of 2026, the pattern wouldn't stay quiet. The trouble clustered wherever routes brushed the L1 and L2 neighborhoods, and it kept the same strange manners the ghost pings had. Precise timing, polite intensity, surgical brevity. Stakes first. These weren't low-orbit dropouts you blame on crowding. These were degradations on the highway that carries every serious mission outward. If the corridor through L1 sneezes, payloads miss burns. If the L2 shell coughs, relays behind the moon go dark. One misstep at those knots doesn't strand a satellite. It changes the calendar. That's money, insurance, and careers. It's also tacit admission that something with rhythm sits at the balance points and responds when we make noise. Action. In January, a commercial lander consortium logged a string of attitude excursions as their vehicle climbed past high elliptical apogee toward translunar injection. The excursions mapped to micromomentary star tracker blindness lasting less than a second. The path crossed the L1 funnel. The engineers scrubbed, recalibrated, and flew again. Same behavior, same altitude band, different time of day. In February, a National Space Agency testbed, riding a free return arc, reported unexpected spectral congestion on a deep space transponder during a pass through the L2 approach. The signal wasn't jammed. It was gently crowded, like a hand resting on a microphone. The ground switched to backup and wrote it out. Meanwhile, privately, operated telescopes started flagging something that didn't belong on their screens. Not objects, gaps. Narrow, temporary holes in background radio quiet that tracked with translunar traffic like wakes behind a boat. An academic lab in Europe published a dry note about transient line-of-sight obfuscations consistent with structured interference. It was paywalled, dull, and read by exactly the people who needed to read it. A week later, the lab retracted the note and replaced it with a study about antenna calibration. Microstory. A Starship test climbed out of Boca Chica on a heavy day, booster thunder rolling the Gulf flat. The ascent went clean, the stage did its ballet, and the upper vehicle settled into a parking orbit. Minutes later, as engines lit for the long push toward the moon, 3 steady points formed above the band where space looks like sky. Not stars, too steady, not vehicles, too quiet. Phones caught them from a dozen angles. They held their equidistance, softened and dissolved. The mission proceeded, but the ground reported a brief need to switch frequency. The timeline said nominal. Here's the cadence that broke denial. Every burst of launch activity, every window where multiple vehicles raised orbits towards Cislunar, brought a rise in anomaly flags around L1 and L2. The flags weren't random. They tracked with our schedule, like a metronome we didn't set. A rideshare flight to high orbit produced a small blip over L1. A pair of geosynchronous deliveries stacked close together produced a bigger one. A cargo mission to a near-rectilinear halo orbit behind the moon produced the largest, centered on the L2 approach, with sidebands that looked suspiciously like handshake tones. Operators adapted. Procedures shifted to include short, pre-planned comm handoffs just before vehicles entered the sensitive shells. Mission control floors posted timing cards that looked like blackout schedules, except nothing went dark. everything went prudent. The Space Force dashboards rolled anomaly heat maps into the planning tools, so commanders could buffer busy windows. No one called it deconfliction with a non-cooperative participant. They called it resilience. The effect was the same. We moved around something that didn't move for us. Impact. The response exposed intent without a confession. If the Sentinel geometry wanted to harass, it could drown links, not nudge them. If it wanted to hide, it could stay invisible, not paint faint triangles that the public can film. Instead, the behavior looked measured and conditional. When our traffic surged, the patterns tightened. When a collision risk rose in high orbit, the interference in cislunar space briefly increased, then fell away faster than models. It acted like a network enforcing rules on a lane, not like a fleet playing games in the sky. Microstory. A flight dynamics team at a private firm watched their tools throw unmodeled acceleration warnings during a tranlunar injection. The numbers were tiny, like a breath on a pendulum, but the timing lined up with a known anomaly window over the L1 corridor. Their lead wrote a note to clear the flags and ran the burn longer by a sliver. The trajectory settled back onto the line like a coin dropped into a groove. Weeks later, he looked at his own change log. He had written, compensated for corridor weather. He had never used that phrase before. Meanwhile, insurance underwriters adjusted fine print to include network-induced comm degradation. Launch brokers added a new disclosure question about corridor timing. Academic telescopes tuned their surveys to avoid low-frequency bands during heavy cislunar traffic, citing self-generated interference. The language stayed bland. The behavior wasn't. Everyone acted as if something upstream noticed our pushes and responded with gentle gates. This was the moment everything changed because it didn't look like a moment. It looked like a slow normalization of moving around a protocol we don't own. We started treating L1 and L2 as toll plazas, not scenery. We built buffers into our burns. We accepted that brief, polite losses of lock weren't bugs. They were the system taking attendance. And standing on the other side of that realization was a map the public hadn't seen yet. Triangles tightening exactly when trilateration would be most effective. The Sentinel geometry turning into